Hello there, it's Mr. Payton. How are you? Thanks for clicking on the help video. I'm going to be working through the 6.13 equations and two variables on your own section. So let me flip the camera around here. Okay, so we're in the on your own section in the practice part of the 6.13 lesson. A cell phone user's bill shows a breakdown of the charges for the month. There's a $25 monthly fee and the customer pays $5 for each hour of talking. What are the variables in this situation? So we're looking for the independent and the dependent variable. So let me just click into the lesson here and take a screenshot of this. All these two variable equations are going to have a dependent variable and an independent variable. The dependent variable is like your final answer to the problem. It's always just going to be y. Nothing is going on with it. Its value depends on what you plug in for x. And that's why we call y the dependent variable and x the independent variable. So what's this look like with this particular problem? We could say y is equal to a monthly fee of $25 and $5 for each hour of talking. So I would write this like y is equal to $5 per hour talking plus that $25 monthly fee. So my x, my independent variable, would be the number of hours talking. $5 for each hour of talking, it says here. So x would be number of hours talking. Number of hours talking. So I think that's going to be my independent variable. And the dependent variable will be the total bill. 25 is a constant here. That's never going to be a variable. And it didn't talk about text messages at all. Just talked about the number of hours talking. There we go. Well, let's look at the next one. Donald is saving money to buy a present for his dad. He earns $9 an hour washing cars. What are the variables in this situation? $9 per hour. So it looks like the independent variable is going to be the number of hours. I would write this like this. Y is equal to 9x. If x is number of hours working, $9 per hour, I know they're calling it h, but that's the number of hours worked. So if he worked 1 hour, you just get paid $9. If he worked 2 hours, we do 9 times 2, $18. So our independent variable, you got to be careful with these because even I get them flip-flopped sometimes. The dependent variable here is y, dependent. It's always going to be by itself. That's going to be after however many hours he works, his final paycheck. So the total amount that Donald earned would be the dependent variable. It depends on how many hours he works, right? The number of hours he works is the independent variable here. 9 is a coefficient to that variable. It wouldn't be a constant, but it's also not a variable. And they didn't say anything about the number of presents Donald will buy. Well, let's check it. That checks out. Next. This table shows the relationship between the variables x and y. Which equation best represents the relationship between x and y? So what I like to do is just look at what are we doing to the x value to get the y value here. Let's pop this on the board here. What am I doing to the x to get to the y? Can't really tell much with the zeros, but how do I get from 1 to 5? possibly multiplying by 5. That looks like times 5. Does it work for all the rest of them? Is 2 times 5 10? Yes. Is 3 times 5 15? Yes. Is 4 times 5 20? Yes. How about the zeros? Is 0 times 5 0? Yeah, it is. So to get from x to y, we're multiplying by 5. So our y value here, the dependent variable, would be 5 times my x. 5 times my x. Now be careful here. There's other patterns you can see here. Like if you look down the column of y values, it's going up by 5, plus 5, plus 5, plus 5. And that's because the x values are going up by 1, plus 1, plus 1, plus 1. But the equation you want to get from x to y is you're not going to do this. X plus 5. This is the mistake a lot of people will make. That will not work. Think about it. If you plugged in 1 for x, then your y value would be 6. And here we're told it's 5. If you plugged in 2 for x, your y value would be 7, not 10. So that doesn't work. So the equation that works will be y is equal to 5x. This one right there. Bingo. Let's go to the next one. The table shows the relationship between the variables x and y. Which equation represents the relationship between x and y? Again, we should be able to do this without even looking at the answer options. Let's just put it on the board here. How am I getting, what do I do to the x to get the y? That's really what I'm thinking about here. What do I need to do to the x to get to the y? So let's see. 2, how do I get from 2 to 4? I can add 2 or I can multiply by 2. These are all going to be multiplying here, guys. Sometimes we do have things added as well in the equations, but that's going to be on top of the multiplying. So 2 times 2 makes 4, 3 times 2 makes 6, 4 times 2 makes 8, 5 times 2 makes 10, 6 times 2 makes 12. That checks out. I believe the equation is going to be y is equal to whatever my x is times 2. So I'd write that as 2x. Y is equal to 2 times x. That works for all of them. And I could even plug in a new x value and get a new y. All right, let's look at our answers. Yep, that would be this one right there. Next. Same question. Which equation best represents the relationship, let me make it a little bit bigger for you guys, between x and y? Well, now I can't get it all in one screenshot. There we go. What patterns do you see here? Okay, so how do I get from 2 to 6? 2 times 3 makes 6. Let's try that. Does that work for the rest of them? Is 4 times 3 12? Yes. Is 6 times 3 18? Yes. Is 8 times 3 24? Yes. 10 times 3 30? Sure is. So your y value is going to be your x value times 3. And you could, I guess, write it like this, but just typically we put that 3 on the other side of the x. Y is equal to 3x. We don't even usually use the multiplying sign, just write it next to each other like that. Anything you plug in for x is going to get tripled here to make the y value. The y value is the dependent variable. It depends on what you plug in for the x value, our independent variable. Hopefully that's legible enough. So how about other patterns? Let's check out if we look down the column, it looks like it's going plus 2, plus 2, plus 2, 2, 4, 6, 8. We could have numbers in between here. I mean, what if I had a 3 for the x value? Well, 3 times 3 would make 9. Our 9 value would be, our y value would be 9. But the x values are going up by 2. The y values are going up by 6, it looks like. 6, 12, 18, 24, plus 6, plus 6, plus 6. But how we're getting from x to y, we're multiplying whatever x is times 3. So it's going to be y is equal to 3x. And the rest is garbage. Okay, check answer. Yeah, looks good to me. Are the data described discrete or continuous? The number of gallons of water used in a shower during a person's shower. The number of gallons of water. So here it gets a little bit murky sometimes. Remember, discrete is it's something countable. Like if I'm only measuring in gallons, like if I can only have 1 gallon or 2 gallons or 3 gallons or 4, and I can't have anything in between. I can't have 3.5 gallons. If for some reason I could not have anything in between the whole numbers, then it would be discrete. But when we're measuring gallons, it's probably going to be somewhere between the integers, maybe 1.5 gallons, maybe 5 3/4 gallons. And when we're measuring stuff like that, and for to have all those possibilities, it's not countable. That would be considered continuous data. Continuous data. Both gallons of water and time can be divided into fractional units, so the data is continuous. How about this? We have ourselves a little graph. Since the graph is a smooth line or pattern of disconnected points, looks like a line to me, a ray actually. Since it's a ray, the data in the graph is continuous. Now, this is kind of a generic graph. It's not labeled. We can't really get any real data from this, but it shows time along the x-axis and distance along the y-axis. We should be able to pick any point in time, run a line up to this line, the graph here of our data, and then follow it over to the distance and get the distance in miles that go along with that amount of time. So that is another example of continuous data where you'll see a line instead of individual data values. Next, are the data described discrete or continuous? The dance school has 21 students. Okay, so that's something that's countable, right? I mean, we can't have 21.5 students. It's 21 exactly. If there was one fewer student, there'd only be 20. If there was one more student, it'd be 22. That's a great example of discrete data. There's no in between. If we were to plot information having to do with these students, it would be discrete data. All right, check answer. Yeah, all right. Okay, select from the drop-down menu. Yep, I'm seeing the dots. I know right off the bat that's discrete. You see the dots? You know it's discrete. The graph is certainly not a smooth line. It's a pattern of disconnected points. The data in the graph is discrete. Discrete. It looks like we're talking about people here and the cost of something. So that should be right. All right, next. Write, oh, this is a good one. Write a table of ordered pairs from the points on the graph. Drag and drop them into the boxes. Okay. Well, let's put this on another screen. Well, let me blow it up a little bit. X and Y values with all these points 0, 1, 2, 3, 4, 5, 6, 7, and 8. How about I just copy this over and we can write in the numbers? Well, I'll copy those too. That's a little large. Don't think I could actually adjust this here. Well, I'll just do my own. How about I make my own little T-chart here with an X and Y. With all those numbers, it was 0 through 8. We have to use all those numbers to write a table of ordered pairs from the points on the graph. So where are the points on the graph? You see them there? The dots are connected, but we have separate points here. The first one is at 0, 1. 0, 1. So let me actually get a different color here. 0, 1. Why is it 0, 1? Because its x value is 0. It's not going left or right at all. And the y value is 1. Remember, your x value is how far left and right. Y value is how far up and down. X comes first, then y. 0, 1, so I'll do a 0 for the x and a 1. These colors are weird. 0 and 1, like that. Okay. The next point, it looks like it's over 2 up 2. So that one right there, I'd say it's 2, 2. 2, 2. The next point, over 4 up 3. So 4, 3. 4, 3. The next one right here, over 6 up 4. 6, 4. Those are my ordered pairs, just broken out into this this chart or this table. So to answer this in here, you just have to drag it. So what did we had? We had 0, 1, 2, 2, 4, 3, and 6, 4. I guess we did not have to use all these. These are just our options. 0, 1, 2, 2, 4, 3, 6, 4. 0, 1, 2, 2, 4, 3, 6, 4. Looks good to me. Oh yeah, I like seeing all those check marks. Next. Similar to one of the previous questions, we have a table showing x and y values. What equation represents the data from this table? Let's analyze it a bit over here. How am I getting from the x to the y? Well, I can't really get anything from the 0, 0. You could multiply 0 times anything to get 0, but how about the 1 to the 6? Probably just times 6 is what's going on here. 2 to 12, 2 times 6 makes 12. 3 to 18 times 6. So our y value, our dependent variable, depending on what we plug in for x, it is going to be 6 times that. If we plug in a 1 for x, 6 times 1 makes 6. If we plug in a 2 for x, let's look at this one right here, how that looks. They're saying 12, which is the y value, is equal to, if it is 6, 6 times 2, 6 times 2 is 12, so we get a legitimate equation there. So I think the equation is y is equal to 6x. There it is. Good to go. Another one, same question. How do we get from the x to the y? Every one of these is going to be multiplying. It's going to be multiplying by something. You'll find that if you think it's just adding, it's not going to work for every one. Okay, like how do we get from 2 to 8? You can add 6, but that's not how you get from 0 to 0 or 4 to 16. It looks like there's the other patterns I see. It's like plus 8 down here, plus 8. Going down the x column, we got plus 2, plus another 2, plus another 2. Sometimes you'll see problems where they're missing. It might missing where like an expected value. Like I could have given you this without the 2 and 8, for example. What if I just gave you 0, 4, 6 and 0, 16, 24? You'd still be able to do the exact same thing. Just figure out how to get from x to y. How do we get from 4 to 16? I think that's just times 4. How do we get from 6 to 24? Times 4. The 2 to 8 there, also times 4. And you could multiply 0 times 4 to get 0. So y is going to be 4 times my x value here. All right, this video is kind of going long. I'm already at 20 minutes. All right, let's do the last two. This graph shows a relationship between x and y. Which equation represents the data from this graph? All right, good one. Oh, good. This is a little bit different. Let's put this up. All you have to do with this is, I mean, I don't need, don't, some of these answer options are, I mean, well, 3 of them are wrong. So they're just there because it's a multiple choice question. You could do this without any answer options and might even be easier because you don't have any sort of decoy ones to confuse you. Now with this data, with this graph, you can come up with x and y values. We got one right there, 0, 0. We got, let's make a little table of x and y values. 0, 0, right there. 1, 4, over 1 up 4, right there. Another one right there is over 2 up 8, 2, 8. So now just do what we did to the last problem. How do we get from x to y? There might even be more we could pull out of here. If you look along the line, it might be a little bit hard, but like right there, I think that's 1.5 for the x value and 6 for the y value. We could see if that works too. How do we get from 1 to 4? How do we get from 2 to 8? Looks like we're just multiplying by 4. 1 times 4 makes 4. 2 times 4 makes 8. How about this? Is 1.5 times 4 6? It is. It is. So that would work too. So I believe it's just going to be y is equal to 4 times whatever x is. That is one of the answer options. Y is equal to 4x. Yes. Next. Similar problem. Graph shows a relationship between x and y. Which equation represents the data on this graph? Not even really going to look at those. I'm just going to look at the data. You see the points there? We have another 0, 0. Try making another one of these. 0, 0. That's the first point. Right there. Oh, that's not going to show up. 0, 0. Right here we have 1, 2. 1, 2. Right here we have 2, 4. Here, next one is 3, 6. Next one is 4, 8, I think. There's another one up there, 5, 10. So 0, 0, 1, 2, 2, 4. Let me go back to white here. 1, 2, 2, 4, 3, 2, 3, 6. Okay, I thought I made a mistake. 3, 6, 4, 8. 3, 6, 4, 8. That should be enough. We should be able to do this with just like 2 of these and don't even need them all. The only ones that are a little bit weird are with the zeros. There's not much we can tell just having 0, 0. Because 0 is so special, when you multiply anything by 0, you still get 0. But the other ones we could definitely work with. How do we get from 1 to 2? Well, other than adding 1, I mean, we can multiply by 2. I think it's just going to be times 2. How do we get from 2 to 4? Times 2. How do we get from 3 to 6? Times 2. It looks like we're doing times 2 here. And that will work for the zeros as well. Times 2, times 2, times 2. 5 to get from 5 to 10, times 2. So you want y is equal to 2 times x. Your y value is going to equal whatever twice x is. Okay, that's it. That's it for the on your own questions. Hope this helps, guys. And let me know if you have any questions about any of these. See you in Math Zone, maybe. Catch you later. Good luck.